Hello, this is Jack Jackson. In this playlist, we're going to be talking about some more advanced techniques of integration. And we'll be covering things like basic integrals, using technology to check integration, integration with basic substitution, integration by parts, some trig integrals, including using some trig identities to specifically help us with things of the form sine to the n of x times cosine of the n of x, or tangent to the n of x times secant of the n of m of x. We'll also do some other ones where we might change from other trig functions into sines and cosines and then do them. We'll talk about the technique of trig substitution. We'll talk about rational function operations and how we can use those to integrate rational functions, particularly using long division and partial fraction decomposition. So we'll review some basic things there and use those. We may briefly touch about how to use tables and technology, and we may touch a little bit more on numerical integration that we did earlier, and we'll do lots and lots of problems here. So first of all, you need to realize that this unit is a continuation of my notes from Calculus 1, Unit 5. And of course, I have a whole playlist for that on my YouTube channel. So in those notes and in that playlist, we introduced a basic table of integration and anti-differentiation formulas. And we use it to help integrate the most basic integrals and integrals using the foundational technique of substitution. We also introduced integration by parts, which is the reverse of the product rule for derivatives. Since integration by parts is the inverse of one of the most basic derivative rules, I consider it the most advanced basic technique of integration, and I covered in Calculus 1. Others consider it the easiest of the more advanced techniques, and they first introduced it in Calculus 2. Either way, in these notes we will briefly review basic integrals and integrals by simple substitution and integration by parts, but you should first carefully study the notes from Calculus 1 Unit 5 really before you read these notes. After reviewing these classes of integrals, we will go on to develop some more advanced techniques for finding antiderivatives. These will include using trigonometric identities to find out antiderivative of functions involving trigonometric functions, and completing the square and trigonometric substitution to find antiderivatives of certain algebraic functions. And we will use long division and partial fraction decomposition to find antiderivatives of rational functions. Okay, and throughout these notes, there will be many worked out examples of the three types of integration problems: finding a family of antiderivatives, also known as indefinite integral; finding a specific antiderivative, so an indefinite integral with a initial condition; and finding definite integrals. The first produces a family of formulas, the middle one produces a specific formula, and the last one produces a number. And we will find all the answers completely without the use of any technological aids. We will then use technology such as graphing calculators and GeoGebra to check our work and illustrate our solutions graphically. We will want to apply the fundamental theorem of calculus to find definite integrals. However, for this to be appropriate, the integrand must be continuous over the closed interval whose endpoints are the limits of the definite integral. If the function has a discontinuity at one or both endpoints, or at a point in the interior of the interval, or if one or both of the limits are infinity or negative infinity, then the integral is called an improper integral. And be sure to check to see if the integral is proper before applying the fundamental theorem of calculus. In Calculus 1 Unit 5 notes, we also introduce techniques for dealing with improper integrals, and we'll mix in some improper definite integrals into examples in these notes. Most of these notes will consist of example exercises. You should try to cover up the solutions and work the problems yourselves before continuing on to read solutions. Or if you're following along in the videos, just hit pause and try to work them yourself before hitting play to resume and see what the answer is and to check your answer. So we'll start by repeating the table of integral formulas that we developed in Calculus 1. As always, we can check each of the antiderivative formulas by taking the derivative of the resulting formula function and verifying that we get the original integrand function as the derivative. These formulas are derived and proved and used in the Calculus 1 Unit 5 notes. So at this point, at the end of this video, you need to stop and go back to the Calculus 1 Unit 5 playlist and or notes, if you have access to them from my class, and study that material first, because this is a direct continuation of that unit. I'll go over these in the next video real quickly, but here is the basic table of integration formulas that we derived back in that unit. Here's some for combining function. The third one here is the integration by parts rule. There's some for trig functions, power and exponential functions, hyperbolic functions, and some that we could obtain from trig substitutions, but we did it a different way back in the earlier unit. All right, so we'll dive in with this the next video.